The origins of the world have been a source of fascination and inquiry for centuries. Many cultures and societies have developed various mythologies to explain how the universe came into being, but the most widely accepted scientific explanation is the Big Bang Theory. About 13.8 billion years ago, the universe began as an extremely hot, dense point known as a singularity. This singularity then rapidly expanded in a process called inflation, cooling as it grew and forming matter, energy, space, and time. Over billions of years, this matter began to coalesce into galaxies, stars, and planets, eventually forming the world we know today. Time, on the other hand, is a concept that governs the progression of events. It is often described as a continuous, irreversible flow from the past to the present and into the future. Time is tied to the fabric of space itself through the theory of relativity, which was developed by Albert Einstein. According to relativity, time is not a fixed, independent entity but is intertwined with space in a four-dimensional structure called space-time. The passage of time is relative. It can speed up or slow down depending on factors like velocity and the presence of gravitational fields. Time seems to pass uniformly in our everyday experience, but in extreme conditions, such as near a black hole or when traveling at near light speed, time behaves in strange and counterintuitive ways. A black hole is one of the most mysterious and fascinating phenomena in the universe. It is a region of space where gravity is so strong that nothing, not even light, can escape its pull. Black holes form when massive stars exhaust their fuel and collapse under their own gravity. This collapse creates a singularity at the center, surrounded by an event horizon, the point beyond which nothing can return. The immense gravity of black holes can distort space-time itself, causing time to slow down near the event horizon relative to the rest of the universe. While black holes are invisible to the naked eye, scientists detect them by observing their effects on nearby matter, such as the way they warp light or the powerful X-rays they emit when they consume matter. The question of whether there is another world like ours is a subject of great speculation. Astronomers have discovered thousands of exoplanets orbiting distant stars, and some of these planets are located in the habitable zone of their stars where conditions might be right for life. While none of these planets have been proven to harbor life, the discovery of extremophiles, organisms that live in extreme conditions on Earth, has opened up the possibility that life could exist in environments very different from our own. The search for alien life continues, with missions like the James Webb Space Telescope providing more detailed observations of distant worlds. Aliens, as they are popularly imagined, are beings that exist beyond Earth, possibly on other planets or in other galaxies. While there is no definitive evidence of alien life yet, the vastness of the universe makes it statistically likely that life could exist elsewhere. Scientists are actively searching for signals from intelligent extraterrestrial civilizations through projects like the Search for Extraterrestrial Intelligence, SETI. Many theories exist about what aliens might be like, ranging from microbial life to advanced, intelligent species. Some suggest that extraterrestrial life could have developed and formed completely different from what we understand, possibly based on biochemistries that are not carbon-based. Despite centuries of inquiry, the nature of our existence, the passage of time, and the mysteries of the cosmos remain a subject of ongoing exploration and discovery. Advances in physics, astronomy, and technology continue to shed light on these profound questions, yet many of them remain elusive, encouraging further exploration and wonder about the universe and our place within it. As we continue to explore the nature of existence, we find that our understanding of the universe is ever evolving. The more we learn, the more we realize how much we don't yet know. Concepts like the origin of life, the structure of space, and the deeper mechanics of time remain some of the most profound mysteries. Even as scientists observe distant galaxies and probe the very fabric of space-time, questions persist. Is there a beginning to the universe, or has it always been in some form? Does the universe have an end? And if so, what might that look like? The idea of alternate worlds or parallel universes has also sparked much interest and debate. The theory of the multiverse suggests that our universe might not be the only one. Some versions of this theory propose that there are countless other universes, each with different physical laws or initial conditions, possibly creating entire realms where life as we know it could exist in various forms. These alternate realities are beyond our current ability to detect, but the idea raises fascinating questions. Could there be a version of Earth where history unfolded differently? Could other civilizations exist in parallel dimensions, just out of reach from our understanding? On a more grounded level, our understanding of time continues to challenge even the most seasoned physicists. While time is something we experience daily, one moment following the next, its true nature remains a puzzle. The idea that time could behave differently in different gravitational fields or at different speeds has been confirmed through experiments, but what exactly constitutes a flow of time is still debated. Some theorists propose that time itself could be an illusion, a byproduct of the way we perceive changes in our environment. If that were true, time would not be a fundamental component of the universe, but rather a human construct that we rely on to understand and navigate the world. Then, there's the enigma of dark matter and dark energy, two mysterious substances that account for most of the mass and energy in the universe but remain invisible and undetectable by traditional means. Together, dark matter and dark energy influence the behavior of galaxies and the expansion of the universe, yet their exact nature is still unknown. They serve as a reminder that much of the cosmos is beyond our current capacity to observe or understand. Their discovery has pushed the boundaries of physics and led scientists to question the very foundations of the universe. As we venture further into space and continue to search for answers, questions about life beyond Earth, the nature of black holes, and the fabric of time will remain central to our quest for knowledge. The discovery of microbial life on Mars or beneath the icy crust of one of Jupiter's moons, such as Europa, would dramatically alter our understanding of life's origins and its potential existence elsewhere. It would also raise profound philosophical and ethical questions about our place in the universe and our responsibility toward other forms of life, should they exist. The search for extraterrestrial intelligence, too, remains a frontier of science. Scientists continue to scan the skies for signals that might indicate the presence of advanced civilizations. The sheer size and complexity of the universe suggests that, if intelligent life exists, it could be vastly different from anything we can imagine. Perhaps they communicate in ways beyond our understanding, or their civilizations have evolved in such a way that they are undetectable by current technology. However, this search, while intriguing, also complex and intertwined with the very fabric of reality. How does consciousness arise from physical matter, and could it exist elsewhere, perhaps on other worlds or in forms that differ greatly from what we experience? Could intelligent extraterrestrial life possess a kind of consciousness that challenges our very definitions of sentience? These questions push the boundaries of both science and philosophy, bringing us face to face with some of the deepest mysteries of the universe. As technology advances, the tools we have at our disposal to probe the cosmos become more sophisticated. Space missions, like the upcoming exploration of asteroids, the study of Mars' subsurface, and the examination of distant moons, will not only provide more detailed insights into the makeup of other celestial bodies, but also help answer critical questions about the origins of life and whether it could exist elsewhere. For example, the exploration of Titan, Saturn's largest moon, with its methane lakes and complex atmosphere, could reveal new possibilities for life's existence in environments vastly different from Earth. Similarly, the discovery of subsurface oceans beneath the icy crust of moons like Europa or Enceladus raises the intriguing possibility that life could exist in these isolated environments, shielded from the harsh conditions of space. The search for extraterrestrial life has broadened with the advent of new technologies, such as radio telescopes, that allow scientists to listen for potential signals from intelligent civilizations. Despite decades of searching, we have yet to receive confirmed communication from extraterrestrial intelligence. However, the absence of evidence has not dissuaded researchers from exploring the possibility that life, perhaps even advanced civilizations, exist elsewhere. Some scientists speculate that extraterrestrial civilizations might be deliberately avoiding detection, either due to the vast distances between stars or because they adhere to a kind of cosmic prime directive, a policy of non-interference with less advanced species. Other theories suggest that aliens might be so different from us in terms of biology or technology, that we would fail to recognize their signals, even if they were broadcasting them. On the other hand, the question of the future of humanity itself is equally compelling. The exploration of space is not just about uncovering the mysteries of the cosmos, but also about ensuring the long-term survival of our species. As our planet faces the challenges of climate change, resource depletion, and geopolitical instability, humanity's ventures into space might serve as a way to safeguard against existential threats. Colonizing other planets, such as Mars, could provide a backup for human civilization in the event of catastrophe on Earth. However, this also raises a host of ethical and practical challenges. Should we expand to other worlds? And if so, how can we ensure that we do so responsibly? What rights would inhabitants of these new worlds have? And how would we ensure that we don't repeat the mistakes of our history of colonization and exploitation on Earth? Moreover, advancements in artificial intelligence and robotics are also pushing the boundaries of what it means to be human and how we define intelligence itself. AI has the potential to revolutionize everything from space exploration to the search for extraterrestrial life. As we continue to develop increasingly advanced machines, we must confront the question of whether we are on the verge of creating beings that possess a form of consciousness or intelligence far beyond our own. This idea brings with profound ethical dilemmas. If machines become capable of independent thought and decision-making, what rights and responsibilities would we have toward them? Would these advanced AI systems be considered life forms? And if so, how should we relate to them? Throughout all of this exploration and discovery, the underlying question remains: what is the ultimate purpose of our search for knowledge? For many, it is not just about finding answers, but about expanding our horizons and understanding our place in the universe. As we stand on the cusp of new discoveries, we are reminded that our journey into the unknown is as much about the journey itself as it is about the destination. The quest to answer fundamental questions about existence, time, black holes, and extraterrestrial life is also a quest for meaning in the vastness of space, in the mysteries of life, and in the very nature of consciousness. In the future, as our understanding deepens, we may come to realize that many of the answers we seek are not final or definitive, but part of a much larger and more intricate web of understanding. Perhaps, in time, we will discover that the universe itself is not just a cold, impersonal expanse, but a dynamic, ever-evolving entity, full of complexity and wonder. As our knowledge grows, so too does our appreciation for the mysteries that remain, mysteries that will continue to inspire humanity for generations to come. Ultimately, the questions we pose about time, the universe, and our place within it will likely never have a single, definitive answer. Instead, they will evolve with us, leading to deeper reflections about existence, consciousness, and the nature of reality itself. And as we venture forth into the future, whether through space exploration, the pursuit of scientific discovery, or the quest for understanding, we will continue to seek out the answers that connect us not only to the cosmos, but to each other, to the Earth, and to the very essence of what it means to be alive. Raises profound existential questions about the nature of humanity. If we are not alone in the universe, how would that reshape our understanding of ourselves? Would it unite humanity in new ways, or could it lead to existential anxiety about our place in the cosmic scheme? In essence, the pursuit of answers to questions like how the world came into being, what time is, what black holes represent, and whether we are truly alone in the universe is ongoing. Each answer we discover leads to even deeper questions, and each mystery uncovered reveals just how vast and complex the universe truly is. Whether through the exploration of distant planets, the study of the fabric of space and time, or the search for signs of alien life, humanity's curiosity remains a driving force, propelling us forward in our quest to understand the world around us and the forces that govern it. The mysteries of the universe are not just about scientific exploration. They also reflect our deep philosophical need to comprehend the unknown and to find meaning in our existence. As we continue to push the boundaries of our understanding, the mysteries of the universe inspire not only scientific curiosity but also philosophical contemplation. Every new discovery in cosmology, physics, or biology opens up further questions about the fundamental nature of reality. For example, the discovery of exoplanets in habitable zones raises questions about the uniqueness of Earth and the possibility that life could arise in conditions very different from our own. The thought that we might not be alone in the universe has profound implications for humanity, sparking both excitement and existential questions about our role in the grand scheme of things. The discovery of life, even in its simplest form, on other planets would challenge many of our assumptions about life's origins. It would also force us to reconsider the conditions required for life to exist, potentially broadening our understanding of what constitutes a livable environment. We tend to think of life as we know it, carbon-based, dependent on water, and requiring oxygen or other gases for respiration. But the discovery of life forms that operate on entirely different biochemistries could redefine our entire framework for understanding life. This could lead to the realization that life is not a rare anomaly but a more common phenomenon in the universe than we ever imagined. In addition to the search for life, the exploration of black holes, dark matter, and dark energy remains at the cutting edge of scientific research. These phenomena challenge our current understanding of physics and reveal that there is so much about the universe that we still don't know. Black holes, with their immense gravity and ability to warp space-time, raise fundamental questions about the nature of gravity, space, and time. The mystery surrounding them, such as what happens inside a black hole or whether information can ever escape from it, are some of the most intriguing puzzles in modern physics. The recent observations of gravitational waves, ripples in space-time caused by the collision of black holes, have provided new insights into these mysterious objects, but we are far from fully understanding them. Dark matter and dark energy, two of the most significant yet elusive components of the universe, remain a great source of mystery. They are invisible to our senses and undetectable by conventional means, but their effects are felt throughout the universe. Dark matter, which makes up about 27% of the universe, interact with regular matter through gravity but does not emit, absorb, or reflect light, making it invisible. Dark energy, responsible for the accelerated expansion of the universe, account for approximately 68% of the universe's energy content. Understanding these invisible forces is one of the greatest challenges of modern astrophysics, and solving these mysteries could unlock new insights into the workings of the cosmos. The questions surrounding time also continue to puzzle scientists and philosophers alike. Time, as we experience it, seems to flow in one direction, from the past through the present and into the future. But in the realm of quantum mechanics and general relativity, time behaves in ways that defy our everyday experiences. In black holes, for instance, time is thought to slow down near the event horizon. In fact, at the singularity at the center of a black hole, time may cease to have any meaningful definition. Some theories even suggest that time itself may not be a fundamental component of the universe, but rather an emergent property that arises from deeper, more fundamental processes. The idea that time could be an illusion is a radical concept that challenges the very nature of reality and perception. As we delve deeper into the nature of space, time, and the universe, new technologies and innovative ideas continue to reshape our understanding of the cosmos. Space telescopes, like the Hubble Space Telescope and the recently launched James Webb Space Telescope, are providing breathtaking images and data that reveal the universe in unprecedented detail. These instruments allow us to peer into distant galaxies, star systems, and nebulae, bringing us closer to understanding the origins and evolution of the universe. In the future, advances in quantum computing and particle physics may offer new ways to probe the fundamental building blocks of matter and energy, possibly even unlocking new realms of knowledge about the universe's creation and potential for life beyond Earth. Despite the incredible progress we've made, the quest to understand the universe is far from complete. Every new discovery seems to lead to more questions, creating an infinite loop of inquiry that has driven humanity's exploration of the unknown. Whether we're contemplating the possibility of other worlds, the nature of time, or the existence of intelligent life elsewhere, the answers remain tantalizingly out of reach, yet within our grasp. The future holds the promise of new insights, new discoveries, and perhaps even answers to some of the most profound questions humanity has ever asked. In the end, the search for knowledge about the origins of the universe, the nature of time, and the possibility of life beyond Earth reflects a deeper human longing to understand our place in the cosmos. It is a journey that has been underway for centuries, driven by the innate curiosity of human beings to reach beyond what is known and to seek understanding in a vast and mysterious universe. And as we continue on this journey, we may uncover not only the secrets of the universe, but also new perspectives on our own existence. As we continue to explore the vastness of space and the depths of fundamental questions about our existence, the boundaries of human knowledge expand, yet they remain elusive. While we have made tremendous strides, there is still so much left to discover. The study of the cosmos often leads us to realize how small we are in the grand tapestry of the universe, yet at the same time, it serves to remind us of the incredible potential for human exploration and understanding. One of the most compelling questions still at the forefront of exploration is the nature of consciousness and the role it plays in our understanding of the universe. As we investigate the outer reaches of space and time, we cannot ignore the fundamental question of what it means to be aware of the universe, to perceive it, and to seek to understand it. Human consciousness, unlike the simple phenomena we can observe, is deeply,